Hey, what's up, Matt?
How you doing, Joe?
Good. How's New Jersey?
It's good. It's very hot and humid here, but I know it's warmer in Utah, but we don't have the humidity out there.
Yeah, just like 1,000 degrees and really dry here. It's like a oven or
Your
something.
your house is about to spontaneously combust.
Uh, yeah, give it some time.
Yeah.
So, yeah, awesome. This week you had something you wanted to talk about that's been in your mind a lot.
Yeah, I mean, I've been thinking a lot lately about the trend toward the re-emergence of SQL in data science and analytics. And by that specifically, I mean that, say 10 years ago, in the early days of Hadoop, there was kind of this understanding that if you were serious about big data, then you had to bring in some heavy duty tools and maybe some heavy duty programming. So that was probably going to be things like writing MapReduce jobs in Java, maybe Pig, if you wanted something a little easier to use. And then over time, what we saw is that SQL became available in more and more big data systems. And so for example, you have BigQuery coming out. And unlike the really early MapReduce at Google, BigQuery, everything is exposed through SQL. Originally, that was a custom dialect, and now it's standard SQL 2011. So it's fairly portable in the industry standard. You have tools like Redshift, you have Snowflake, all handle large quantities of data, and all are still based around fairly standard SQL languages.
Yeah, I mean, I remember this trend. It was the late 2000s, early 2010s. It was that I think there was a lot of banter about how NoSQL was going to take over the universe, and
Yeah,
SQL was like a dying. I mean, you may as well be learning like Latin or something, right? Because that was about as relevant. Let me actually show some slides or some
okay.
tabs related to this as we kind of have a look here. So this is the TIOBE index for August 2020. But what I found interesting was when you drill into SQL, I mean, obviously, nothing happened, right?
Yeah,
It's not
it's
like
very
NoSQL came
stable.
and killed it.
Right.
Nah, and again, there's some nuance with the way that this particular ranking is done, but again, it's almost like there was a data anomaly actually because it's a straight line going forever,
Right.
um, and and then if you look at can you see this Google Trends? Okay.
Yeah, this is coming up on my screen.
Yeah, so I mean, this was SQL and then NoSQL. So I mean, at least in terms of search, worldwide, uh, since inception of this data
Yeah,
set, there really hasn't been, I would say, any visible movement
right.
with NoSQL taking SQL share. Now there is, I'm very curious about like what's happened over time with the SQL search in general, especially that it encompasses China, which is kind of interesting because China isn't supposed to have Google, but that's a story for another day.
Yeah,
And so, given these trends, what I find interesting is there's really good marketing departments at some of these companies that are selling, alternatives to SQL. But I think to your point, at least what I've seen is um, all the technologies that came out in the hopes of beating SQL and removing it from the face of the earth inevitably have, uh, I would say for the most part, have embedded some sort of SQL dialect into their workflow. So
yeah,
it's a
yeah.
cockroach that keeps on cockroaching, I guess.
Well,
So
yeah, back to what I was saying earlier about big data. For a while, I think the outlook was, hey, SQL is in decline. It's not coming back. Eventually, you're going to use these other data frame languages to process data. And then all of a sudden, you saw SQL, at least in the analytics space, just start to ramp up again and show up in more and more tools. I
yeah,
mean, I'd be curious to find data sets that are real specific to analytics and data science that show this happening. But what we do see is so BigQuery, Snowflake, Redshift, SQL is all the primary language for all of those. That's how you access data in those systems. And you also have these very powerful transformation engines. So it's not just that you can pull out, do some basic filtering. You can do all kinds of complex joins and transforms of data before you do some other data science on it at the end.
yeah. I mean, we're talking to somebody earlier today about their use of R, and how
Yeah,
much they loved it. But at a certain point, R isn't really going to scale on your
exactly.
machine, especially. But if you know SQL, then you can tap into potentially limitless compute and query that way, and then you can do something with R on top of it. Yeah, that makes
Yeah,
a lot of sense. I think part of the resurgence too is data science and languages like R and Python really taking data frame constructs and making those a first-class citizens. And then once you understand what's going on with data frames, it makes a lot more sense to maybe take a step back and say, well, okay, so I can run this on my computer sometimes, usually. But what if I needed to scale this to, say, big data? How is that going to work?
exactly.
And so,
And what's big data these days? I mean, even a terabyte, how many machines can handle a terabyte of data? And that's not very big by modern standards.
it's not very big by
Once you start
modern
looking at,
standards.
yeah,
The interesting thing with as an aside on the big data
yeah,
notion is it's like, I think a lot of companies, back in the day, I think we may have touched on this before, but this is definitely like
yeah,
this big data measuring contest where it's like, well, I'm dealing in terabytes. How much data are you dealing with? But now that's like a laughable
yeah,
amount, period. But it's interesting seeing the spectrum of data size at some companies where I would say most companies are in the low gigs actually of data, and trying to apply these very beefy solutions to with a very small data set. But then you get into larger companies in the petabytes, and it's a different type of problem you have at that point. But
yeah.
again, SQL can address all of these. I mean, if you aren't using a small data set, you could put it into a database, even a Postgres database, and query just fine. Not even a problem. So,
And that's the point with SQL. You have this portable language that you can use from small data all the way up to exabytes potentially. And you have a huge number of off-the-shelf solutions. I mean, you can just go sign up for Redshift or Snowflake or BigQuery and be querying massive amounts of data within a few minutes with a very standard language. And I think even with Spark, we've seen more and more promotion of Spark SQL. And again, the reason is I can write custom Spark data frame code, but why would I do that when I can write in a portable language instead and do most of the same things?
yeah, it's one of those languages that's definitely portable across data
Yeah.
sizes. I would also say it's portable across domains and areas of concerns, right? So tell me another
Yeah.
language where that's used, I would say, universally across a company.
Yeah.
Right. So DBAs might use it. Report writers would definitely use it. Application developers would use SQL, whether it's interfacing through an ORM or writing the code themselves. And I'm hard pressed to think of another language where it's that universal.
Yeah. And where it's been such a big language for so long. I mean, starting in the 70s, IBM developed SQL. And yeah, we've seen a slight decline maybe since 2004, but it's still kind of at the heart of modern tech. You're going to see SQL show up in almost any project that you work on.
Yeah. Yeah. I always could relate it back to the Lindy Effect, which is, in stuff like technology, there's definitely this phenomena where the longer something's been around after a certain point, the better chance that thing has to be around for the future. And SQL is definitely one of them. I would say, no matter how hard people have tried to displace it, like we talked about just a second ago, it's been impossible to knock off. An unlimited VC funded marketing budget hasn't been able to do it. Developer preferences haven't really changed. In fact, they seem to be reverting back, I would say anecdotally. I was definitely one of those people that would,
Trash talk it
Python.
At one point. Yeah.
I don't know that trash talked it, but I would definitely,
Okay.
I was open to maybe experimenting with like other ways of maybe doing stuff like, Pandas, I think addressed a lot of issues, but then you're like, well, that's great, except why don't I just do this in a database instead of files? So
yeah. And especially with the
kind of what it came
emergence of
back
cloud
to.
data warehouses that are very low friction, where I can just go and flip a switch and have a cloud data warehouse that will scale. That's such a simple solution. Even installing Pandas on your local machine is more work than that. Installing R on your local machine is more work than that. And it's not that SQL is unlimited. There are a lot of statistical operations that are better done in other languages, but it's that old cliche about what data scientists spend 75% of their time just acquiring and cleaning data. That's where SQL really shines. And you can do some really heavy duty cleaning and pre-processing, data engineering, data pipelines just using SQL if you know how to do it.
Hmm. So, I mean, you had some thoughts too. I remember in one of our chats where, you know, you maybe had some areas where people could improve with SQL.
Yeah, I think there's this culture of using SQL without modularizing it. And by modularizing it, I mean things like you were talking about, create views, right? If I have some real complex thing that I do all the time, then just create a view or maybe materialize it as a table. And then using common table expressions and just breaking things out into smaller modules so that I'm not trying to cram a bunch of functionality into one massive query that becomes completely unreadable. I think there's this attitude in the analytics world that you hit a certain degree of complexity with SQL and then it just becomes unwieldy. But I think that's really just a product of our inability to modularize. Also documentation, right? Like documentation is a huge pet peeve of mine with SQL. I so often see these queries that will like join 3 tables, do some text processing, do some kind of aggregation, then a group by, then a window function, no documentation, a bunch of inline subqueries, just completely unreadable. And that means that if someone hands that to me, I can't really evolve that code. Maybe I can spend 2 weeks trying to understand what it does, but it's very hard for me to improve upon that or customize it for some analytics or data science process I'm working on. And so I feel like all of us kind of need a bit of retraining on how to write modular SQL, and that would really improve the capabilities of the language.
Yeah, I tend to agree. I mean, especially given the diversity of people who could use SQL. You know,
Yeah,
again, like DBAs, report writers, devs,
yeah,
etc. It's, you know, say that those do the thought experiment where like you had a team of people using SQL, teams of people using SQL. I mean,
hmm,
who's going to enforce code standards across all those teams? Because
yeah,
normally that's, you know, that, well, then you're jumping into, you know, waterfall at that point, telling people what to do, not letting the team decide their standards. And so, you know, I mean, I get it. It's, for me, it's a question of like, how are you going to do that? So if
yeah,
you want to have people writing better SQL, you know, it's like if you look at the Python language, like it has PEP 8, and that really enforces,
yeah,
I would say, some explicit standards for you know, how to write proper Python. In a code review, for example, it's like 79 characters. That's the limit for the length of a you know, and so things like that, and indentation. That's another one. You know, I mean, Python was meant to be readable, and SQL certainly is meant to be written however you want to write it, and that impacts everybody who's downstream and has to read what is
yeah.
either elegant code or you know, absolute gibberish.
A horrifying mess. There's this old joke about Perl, that Perl is a write-only language. And that's because people write this terrible Perl script that, I don't know, uses a bunch of text processing that you just can't read at all. Like the person writing it sort of messes around with the low level details, regular expressions and everything, gets it right, does some testing maybe, and then puts it into production. But then if they come back 2 weeks later, they can't even tell what they did. And I feel like the same thing often happens with SQL. It's like we very much just hack it together, get it working, but we don't modularize it, we don't document it. And as far as waterfall processes, I feel if we can just get analysts and DBAs and data scientists into the habit of committing, just putting this in Git repos, and then having people look at their code and just say, hey, why don't you go add some documentation to this before I merge it? That would make a huge difference.
Yeah, yeah, I can get behind that.
Yeah,
I mean, it's yeah, it's fundamentally a human nature issue. I mean,
right.
because I mean, you see some companies spending a lot of, you know, resources developing tools for data ops, and bless their heart. I mean, please, by all means, do that. But at the end of the
Right.
day, you're dealing with um, your biggest barriers is laziness,
Right.
and people taking the path of least resistance, and lazy in a good way because they're focusing on the things they need to do to get their job done. And if it
Right.
works today, and it works tomorrow, and it's acceptable by everybody else, and I guess it's okay. That could also
Right.
mean that things like documentation, maybe that maybe the lack of documentation is acceptable by the team, right? Because everyone's very busy. I mean, obviously, these ideas do come back to haunt you in the form of you know, high interest debt later on. But um, you know, I would say it's, if some teams are fine taking on that debt, then it kind of is what it is. You know, I mean, it sucks, but I would say that those teams will inevitably have they'll suffer from issues as a result
Yeah.
of that. I mean, because nothing's free in this world, but it's just a matter of convincing people that doing this is the right thing to do. It's sort of like telling people that they need to floss their teeth every day. I mean, it's a great thing to do, and you should totally do it. And the number of people who maintain that habit over time, I would say, is pretty dang small. Dentists are busy for a reason, so
Right.
you know, it's just again, you're competing against just everything else in the person's calendar to get this done.
Yeah.
But
Well,
that
what I
said,
would
I
say is
would
it's almost
support it.
like well, and I would say it's almost like a tragedy of the commons. In other words, it's like me, having a really polluting car. Other people are polluting. Like, there's not much of an incentive for me individually to not drive around a car that's blowing out black smoke. That it's more of a global problem, or even a problem across your county and country. And if my incentives as a SQL developer are extremely short term and extremely individual, then it kind of makes sense for me to write crappy code. The problem is that it reduces long term productivity and it reduces team productivity. And so, as you're fond of saying, what is it? Show me an incentive and I'll show you an outcome. If you focus
Yeah.
on those short term individual incentives, then the team isn't going to work very well together and they're not going to be focused on the long term. And so somehow you have to have like a higher level structure that says, hey, this is a priority. This helps my company over the course of months and years, as opposed to just looking at today.
Yeah, even simple stuff like having style guides,
Yeah.
code guidelines, and even just simple tests for your code. I mean, I
Yeah.
mean, hell, in dev, that's pretty table stakes, right? And for some reason, in data science and analytics, SQL code is still very arbitrary in that regard.
Yeah, that's
And
absolutely true. Whereas we
the
should be
problem with
testing for
well, the problem with data too is we're always fond of saying that data is a silent killer. Like you may
Yep.
have an issue in your data and may not know it until you've made a decision and you come to feel the effects of that, several months. Whereas with an application, you can write unit tests, for example, and find out if your code will break, either with the code you've written or upon introduction of new code. And so that it's very explicit. It works or it doesn't, right? It passes tests or it doesn't, or somehow, in an edge case, it's not caught by a test, it breaks in the field, but your app is generally a good feedback loop. With an application. With data, unless you have somebody paying attention to the data, how do you know that it's right or wrong?
Yep. And in fact, in many cases, I think we've seen that a lot of people at a company know that data is wrong, but it just seems like too much work and too much organizational momentum to actually change it. And then you have teams that know that they're making the wrong decisions based on bad data, but that's what they're measured on. And once again, it's the incentive thing. If their incentives are tied to that data, then they're going to optimize to that data, even if it's incorrect.
Mm-hmm. Yeah, so this is a interesting can of worms.
It is indeed.
But I do agree in spirit with what you're saying. There needs to be I think higher standards with respect to coding SQL. I'm glad that SQL has lasted this long, but again, even when I look back on SQL code, it's not like there was a time when it was better or worse in terms of standards. It's just always been it always depends on the person writing it. Like if the person writing it has standards and cares, then it's going to be generally pretty good code. If the person is lazy and sloppy and doesn't care, that generally reflects in their work output period, but especially in the code, which is probably still used. And so testament to them. On one hand, they wrote code that is still being used to this day, and I think that's awesome. On the other hand, and maybe that's an interesting tangent for another day. But if the code's working in production for a number of years, is there a problem?
I would kind of say there is, because the business is probably changing. The technology of the business is changing, which means that over time there's some code rot going on, right? It's likely that if this is badly written SQL, then it's not being updated. And then over time, it's producing results that get worse and worse because no one's monitoring its performance.
Yeah.
It won't be true in every case, but I think we've all seen it if we've worked around a company for long enough. There's some old code being used somewhere that's basically rotted. The code itself has stayed the same, but the business has changed, and so the inputs are changing.
Yeah, so that level of complacency is an interesting one, which we can probably
Yeah,
touch on maybe next week or something. Where, yeah, 'cause I'm curious. I mean, we're obviously not going to solve the problem of bad SQL in 20 minutes,
right.
but it's an interesting topic, and I'm glad it was on your mind. So
Yeah, I
cool. So
think,
maybe
I mean,
what's up?
yeah. Oh, I was just going to say, I mean, been more and more convinced of the power and utility of SQL lately. If we can, let's keep thinking about some, ideas for what standards would look like in the future. Maybe we can talk about those in a future chat.
Yeah, that'd be awesome.
Yeah.
Cool. Well, I think that about does it for today. So happy Monday. We'll talk to you later.
Yeah, and stay cool. We'll talk to you
Okay,
soon.
we'll do. All right, later.
Take